You'll have to contain his disappointment. We left off right here. We said what we're going to be using, we have the 4 acceleration equations. They're on that sheet. They're also on your formula sheet. So you either want your yellow formula sheet in front of you, or you're going to be flipping back and forth all the time, whichever you think is less or more convenient. And we said our approach, again, is going to be the little acronym that I gave you was DFIC, which stood for list your data, find a formula, insert the numbers, and crunch the answers. But what I said, Justice, is I'm going to push you to do something called formula manipulation. So here's a physics question. You'll be answering lots of stuff like this. I read, it says a car moving at 30 meters per second to the right slows down, or accelerates to the left, at 9.8 meters per second squared. How far does the car go before stopping? What's this question asking me to find? I would write down to myself, for myself, D equals question mark. By the way, probably technically displacement, but I think I mentioned to you, I get distance and displacement mixed up. I know what you're talking about. I'm not going to be really, really fussy on the notation. I am going to be fussy on the method. So D equals don't know. Now I go back and I read and I see what information they gave me. I see a 30. What's that? I heard the word initial, but what initial? Okay, that's VI. What else do you see? Keep reading. Sorry? Oh. I see an acceleration. Now, I'm going to give you a hint. Be very, very, very careful. Who can tell me what the acceleration is? Negative. I snuck it in. That's why I put accelerates to the left. Eventually, I won't say that. Eventually, Jacob, I'm going to say slows down, and I'm going to expect you to clue in, hey, that's in the opposite direction. I better make that negative. But we're walking before we start running. Negative 9.8. What else? There is one more piece of information. Okay, so one of the things you're going to get used to is looking for words like at rest, or comes to a rest, or stops. Oh, and slows down, speeds up is going to also give you some directional idea as well. By the way, I guess technically that's a vector, that's a vector, that's a vector. Carly, I already said I'm not going to take marks off, but I should do it right in the notes. Hey, I'm looking for an equation that has a D in it for sure, because I'm trying to find D. Has a VI, an A, and a VF. Is there one? Mark, which one? I heard you. Read it to me. I haven't memorized the order, and there is no actual order, so read me the equation, my friend. Yeah. What do we want to find, Mark? We're going to get the D by itself. This is that weird formula manipulation thing that I'm going to push you into. So I'm going to pick on you, my friend. Are you ready? Are you ready? Are you ready? By the way, I would probably make this a 2-mark question, and I would give you either one. I'd probably give you a half mark, just Jordan, for identifying the equation, because I think that's one of the main skills. If you can't find the equation, can't even start. Okay? Mark, my friend, what are we trying to get by itself? D. What side of the equation is it on? I see it there. See it, see it, see it, see it, see it. As I look, I see something in front, but I see this. This is removed from it. I want to move this over to this side. What's the VI squared doing to the D? Adding, subtracting, multiplying, or dividing? So how would I move it over, oh pray tell? So I'm going to have this. The VF squared would drop down like a domino, and I would subtract a VI squared at some point along the way. Oh, I'll even drop down the equal sign so that I clearly know what side is what. So, Mark, I've taken care of the VI squared. I now need to take care of, what else is in front of the D here? What's the 2A doing to the D mathematically? Adding, subtracting, multiplying, or dividing? And you said, how would I move it over then? That's a new equation. That is not on your formula sheet. Chris, I guess you can memorize that. Don't! Please, I'm going to encourage you. Be confident. Wrap your brain. It's going to take a few days, but wrap your brain around this formula manipulation McGillicuddy thing, and you will have cut down on your memorization, Noah, so much you'll be thanking me. Now we can, we listed our data from the defect. We found a formula. I is insert the numbers. So here we go. D equals, Brad, what's VF?
30.
Is,
sorry, 0.
That's why I list my data so I don't trip on my brain like that. I used to not do that. I used to try and do it all in one fell swoop, and the number of times I put the wrong thing in the wrong place drove me crazy. So I said, you know, for 1 second that it takes me to list everything, and it really only, by the time you get good, it'll take you 1 second, Dom. Hey, this is good stuff. So what'd you say, sorry?
0.
0, and then squared, yes? Minus, what's VI?
30.
Squared divided by 2, what's A? Now, this is something all of you need to get good at on your calculator, because every year I see kids write this on the test and then they get the wrong answer. So you want to, all of you, if you have your calculator here, and of course, why wouldn't you have your calculator here? Get your calculator out. Jake, my friend, how many numbers are there on the top? More than 1? I better put the whole thing in brackets. How many numbers are there on the bottom? More than 1? Yeah. I better put that whole thing in brackets. Even though I didn't write a bracket around the top, I'm going to start it going bracket. 0 squared. And this is why I said it's worth getting a nice multi-line display calculator. It helps. Minus 30 squared, close bracket, divided by bracket 2 times negative 9.8, close bracket. I think that's what it's going to look like. One of you guys, because you kind of like go together. Hey, I got, you get 45.9? Oh, hang on. How many sig figs? Let's see. How many sig figs in this 30? 3. How many sig figs in this 9.8? 3. Oh, so I guess 3 in my answer. Yeah, 45.9 meters. By the way, what if I had gotten an answer of negative 45.9 meters? That would tell me that I had moved backwards from where I started from. As long as you're careful with the vectors in the beginning, tailor the answer. Nature will take care of the answers for you, and it'll say, okay, I know what you're getting at, and I'll tell you where you'd end up. It's kind of nice. Example 5. A car travels at 15 meters per second and speeds up uniformly. Over the next 5 seconds, it travels 85 meters. Find the acceleration. Zach, what's this question asking me to find? Yay. But the nice thing in physics, it's usually going to be very clear what they want you to find. It's not like a word problem in math where you're like, what the heck? We're pretty clear in physics. So, Zach, I'm going to write down A equals question mark. And then I'm going to start at the question again. And again, I'm looking for numbers and their units. And I'm looking for physics words, stopped, at rest, speeds up, stuff like that. What do I know? Oh, what's that, Chris?
15.
Darn right. Keep going, Chris. You're on a roll. Things you never thought you'd hear me say.
Speeds up.
Okay, so there's going to be, because it's finding an acceleration. The fact that it speeds up, my answer for the acceleration is going to be what?
Positive.
It's going to be positive. If I get a negative, I've goofed. So nature's got some built-in error checks for me. Keep going. What else do I know?
The displacement.
You went too far. You missed something.
Over the next 5 seconds.
What's that?
Time.
Yep. What if they had said hours? I'd have to do a unit conversion, or minutes, I'd have to do a unit conversion, which we did practice. I will almost always give it to you either in seconds or in hours. Keep going.
Over the next 5 seconds.
Yeah, you got that. What was the next one?
85.
That's a displacement. And I guess technically I should put vector bars over everything except time times the scalar. Am I going to take marks off for that, though? No. Okay. By the way, you're going to find for all of these, you need 3 things to find the 4th. You notice we listed 4 things here. In the previous one, we listed 4 things. You're going to need 3 of them to find the 4th one. It's just a coincidence. Every one of these 4 equations happens to have 4 variables in it Oh, that's a fib. 1 only has 3. I take that back. Hey, I'm looking for an equation that has acceleration, velocity, initial, time, and distance in it. With authority, Zach, my friend. What? By the way, you don't need to say out, we're going to say from now on, if you say VI, I know what you mean. Okay, so D equals, the way you said it the first time, VIT, 1/2 AT squared. If you don't say the word times, I'll clue in you're talking about times. We're going to get lazy. Okay? Okay? What are we trying to get by itself? This is the toughest equation to work with, but we can. We can. When I look at this, Zach, my friend, I see that the A is here, yes? I also see I have this on the same side, a VIT. What's the VIT doing to the A? Adding, subtracting, multiplying, or dividing? Zach, what? So how would I move it over? So I'm going to, on the next line, say the D would drop down, but I'm going to, according to you, I'll be subtracting a VIT. Yeah. And that would take care of this. I'm not going to erase it. You can, in your notes, kind of cross it out as you're doing this if you want to keep track. I don't want to. What am I trying to find, Zach? I got a 1/2 and I got a t squared. What are those doing to the A mathematically? So how could I move both of those over? Divide. I'm going to go like this. Instead of a 1/2, I'm going to write 0.5 and t squared, because I think that's probably what I'm going to type in my calculator. I'm going to type a 0.5. Not too big a stretch, Kylie. You've all learned that. I mean, I know you guys as a generation suck at fractions, but you all know 1/2 is 0.5. Oh, that equals A. Hey, Jake, is there more than one variable on the top? Brackets. Is there more than one number on the bottom? Brackets. Just saying. So all of you, especially those of you that I gave the fancy schmancy calculators to, let's first of all insert the numbers. So we said 85 minus 15 times 5 divided by 0.55 squared. Now I want to point something out that's different between the way I write and the way I calculate type. Okay? Pardon me?
What's that in the bracket?
I don't know, figure it out.
No. It looks like either there's 5.
Yeah, it's messy, but figure it out. You should be able to figure it out by looking at the variables, looking at your data. Figure it out yourself first. Try it. And then I will still answer, but I always tell the kids, don't just copy. Try and say, hey, I know where Dueck got every one of these terms from, right? You got it okay? Mm-hmm. Chris, watch. Everybody watch for a second. Do you know, first of all, Jake, did we say brackets around the top? Okay, so bracket. I'm going to type the 85 minus, I'm going to go 15. I am not going to go bracket 5, close bracket. That's too many brackets. What does this bracket right here actually tell me to do mathematically? It's easier, it's less work, and it's more understandable to read if you just go that, close it off. Divided by more than one term on the bottom. I'm going to do the same thing on the bottom. Instead of going bracket 5 squared, I'm going to go times 5 squared. I'm going to argue that that is way clearer than going 85 minus 15 bracket 5 bracket divided by bracket 0.5 bracket 5 squared bracket. You lose track of the brackets. If it's easier, Jake, when we write to use brackets to show multiplication, absolutely. But because your calculators are one-line displays, Jordan, you lose track of the brackets otherwise. You may have a calculator that lets you do a top and bottom of a fraction and type it in that way, so you might be able to get away with doing it the other way. And if you do, great, because that's a good calculator. Anyways, is the answer 0.8 no matter what?
Yep.
Nope. How many sig figs? 2. How many sig figs? I take that back. 1 sig fig in my answer, 0.8. Units. Meters per second squared. Let's raise the level of difficulty considerably, but to let you know that we can calculate some kind of cool stuff. You've all slid on a playground slide? Yes? One of your great childhood memories. Oh, look, I said you've all slid on the playground slide, and Don back there got this great little grin on his face. Oh, childhood slide, fun. What, just yesterday? Oh, okay, fair enough, fair enough. You haven't outgrown your childhood, that's okay. So a child slides down, or an adult, or a teenager, slides down a playground slide. Accelerating from rest, you know what? I would probably underline the word from rest. And traveling 6 meters in 4.50 seconds. When they hit the ground, their legs bend 20 centimeters as the child stops. What's the child's acceleration in stopping? What does this question want me to find, Sabrina? You know what? Because I see the word acceleration twice, do you see it in front of the words from rest? That acceleration is on the slide. That acceleration is on the slide. And then I see acceleration while stopping. I'm going to go a stop, just so I don't accidentally get them mixed up. Come up with your own this idea of a subscript to label something. Nice, it's short, it's concise, and I'll know what you mean. All right. By the way, this I would consider a nice challenging question. This I would consider like one of the last questions on your test is a good one. Nasty. What do we know? What are we trying to find?
Acceleration.
Okay. Stopping acceleration. All right.
The velocity initial be 0.
Now, I think we have to look at two situations here. I think we have to look at, you know what, let's call it this. And the reason, Chris, you made a great comment. Say what you said again.
I said, could the velocity initial be 0?
I think the initial velocity at the top of the slide is 0. But after you hit ground, what's the final velocity? Also 0. You know what? I think we have to distinguish. I think we have to look at while you're on the slide. That's why this is a tough question. And then while you're coming to a stop. You've been on a slide before? Yeah? A couple times? Okay. You know what? I know what's going through Chris's mind right now. Well, yeah, but I usually run up the slide backwards because I'm that kind of a rebel, mister. I go up. Gotcha. It's okay. No problem. Relax. We all have our little secrets. Chris, I think what happens is you slide down and then you hit the ground. Let's keep going, but I think on the slide, you'll see why I'm doing this in a second. And the reason is, what's that 6? See the 6? What's that? A distance. Hey, what's that 20? Also, see? I think we've got to look at kind of a before and after. So on the slide and on the ground, I think. And I think that's on the slide. Now I'm going to go on the ground. You see, on the ground, I know that. You've been on a slide. What's your final velocity once you're on the ground? Give you a hint. Brad, 0. Zero. What else? Well, the distance this kid's legs bend, the distance he travels is, it's 20 what?
Centimeters.
Can't use centimeters. 20 centimeters, how many meters? Have we reached the point where we can do that in our heads? Let's divide by 100. It's 0.2. Okay? That's the distance conversions that you'll do for the rest of the year. Centimeters to meters and kilometers to meters. You can do the chain. It's all on your sheet, but it's worth memorizing a couple of shortcuts if you're lazy. Here's the problem. I think we got to the end. We've walked through this question, and the problem with this question, this is why this is a tougher question, Justice, is how many different variables have I written here? I said you need 3 to find 4. I've got 2 to find 3. But scooch across where it says on the slide, how many pieces of information do I know? I can use 3 to find 4. See it? Here's our argument. Here's going to be our plan of attack. I would like to know how fast you're moving at the bottom of the slide. V final. Because that speed is going to be your initial velocity when you start to stop. Let me say that again, because this is profound. This is a before and after question, Taylor. I think, you've been on a slide before? I think the speed you're traveling at the bottom of the slide, your final velocity at the bottom of the slide, that's exactly the same as your initial velocity when you hit the ground. We're going to find V final on the slide, and then just swap it over. There's a 2-part question. We're going to say find V final. So even though this question said find the acceleration, I'm going to spend a lot of my time not doing that. Is there an equation that has V initial, D, T, and V final in it? I hope. Is there? There is? Which one? Now, you can write it that way, or I think I said on your formula sheet, instead of dividing by 2, they multiply by a half. Same thing, right? I don't care which one you go with. I kind of like this version better because it's easier for me to figure out what's going on. And by the way, are any of these 0? Yeah? Which one? If anything's ever a 0, it's always worth modifying your equation, because I think what I really have now is D equals VF over 2 times T. In fact, I don't even think I need the brackets anymore because there's only just VF in the brackets. Yeah? Well, then, hey, get VF by itself. What's the T doing to the VF? How will I move it over? What's the 2 doing to the VF? How will I move it over? Are you saying that my new equation, which I'm not going to memorize, is going to be 2, the D is going to drop down, divided by T, that equals V final? Oh, that's kind of nice. How fast do you hit the ground at the bottom of the slide? 2 times 6 divided by 4.5. You may, if you're lazy, instead of typing 2 times 6, you may be comfortable enough to say, hey, that's a 12. Don't be scared to do simple math in your head. Maybe on a test, you might do all the math on a calculator just to make sure you don't make a dumb mistake in your head, but don't be scared in your homework, Zach, to do some of the arithmetic in your head. I'm pretty sure it's going to be 12 divided by 4.5. Will this work out evenly? 2.6666666666. I'm going to write 2.67. I'm going to keep this on my calculator. Big deal. Actually, huge deal. Because now, over here, I can say Because that's your initial velocity, Jake, when you start to stop. You see it, right? The speed that you hit the ground at on the slide is the final velocity on the slide. That's the speed that you start to stop at. That's your initial velocity when you start to stop. That was bad grammar, but hopefully it made sense. Yeah? Okay, I'm looking for, now I have, by the way, Jacob, you'll notice, now I have 3 things that I know to find a fourth. Ah! Hey, is there an equation that has VI, VF, D, and A in it? Dominic, which one?
Velocity final squared.
We can just say VF.
VF squared equals VI squared plus.
He is correct. He said VF squared equals VI squared plus 2AD. Dominic, what are we trying to get by itself? A? All right. Think you can do it? Can you tell me what I'm going to do? Or do you want me to talk you through it? Okay. Where's the A? Left side or right side? Right there? I'm going to have to take care of the 2 and the D, but if you haven't noticed yet, you do the multiplying, dividing stuff last. Is there something else on the same side? There is. This bad boy. How would I move that over? What's it doing to the A mathematically? Adding, subtracting, multiplying, adding? How will I move it over? And so I would probably step by step just kind of start writing already. I'd drop the VF squared down, right? Because it was there already on the left side. And I would say, I guess I'm going to subtract a VI squared. That takes care of that. What else is with the A? A 2 and a D. Hey, what are those doing? How will I move them over? Ta-da! The only problem is I haven't left myself enough room. Give me a second here. This is one of the nice things I can kind of cheat. A is going to be VF 0 squared minus VI. Now I'm going to write 2.67 squared. On my calculator, I'm going to go answer button squared. Because it's not 2.67, it's 2.6666666666666666 forever and ever and ever. Why not be accurate? My technology lets me. If you don't yet know where your answer button is, it's well worth learning. On the fancy schmancy graphing ones, those 3 of you that borrowed them, I think it's second function negative or somewhere along the bottom row there somewhere. Divided by 2 times 0.2. Jake, is there more than one number on the top? Are you saying brackets? Is there more? Are you saying brackets? Yep. Oh, I said I'm not going to do that. I'm going to go answer button, Mr. Dueck. Squared. Do you get? Oh, no, wait a minute. When this kid hits the ground, do they slow down or speed up?
Slow down.
I'm expecting I should have been expecting a negative acceleration. I freaked out for a second, then I went, no, that's actually correct. He's slowing down. Slowing down. Do you remember a few days ago what we said 1g of acceleration was? Dominic? This is just a little bit less than 2 g's. Yeah. When you hit the ground, that's why you have to bend your knees. If you hit the ground with your knees straight, that's a hard shock on your spine. You can actually injure yourself. But you learn very quickly as a little kid, when you're hitting the ground with any kind of speed, you bend. Why? The bigger I can make the distance that my body travels by bending, the smaller that number is going to be. If you divide by a bigger number, you get a smaller answer. That's why it helps to bend your legs when you land. That's the physics of it. I never thought about that. You figured it out when you're 3 or 4, most of you. But that's why. So what do we got? How many sig figs? I guess 3? Is it 3 in my data? I got a 220.0. Is the rest all 3 sig figs? 3, 3. Okay. So, okay, I'm going to have to cheat a little bit again, too. Need a tiny bit more room. Ha-ha! 17.8. Negative 17.8 units. Meters per second squared. I will, if you don't put units on, I'll take a half mark off. Because it's also, Jacob, a way to reinforce it's worth memorizing the units, and the easiest way to memorize the units is just to write them. I've never actually had to say to a kid, you need to go home and memorize the unit. It's Jacob, as long as you write the units, your brain will memorize them. You're naturally lazy. I wrote here lesson 8 exercises. It's a short lesson. I don't want to give you homework for the long weekend. Let me see here. Going to assign number 1 and number 2. Number 3 is like we did in our very first example, except this time I think you have a negative acceleration. See if you can figure it out. Number 4. That's the homework that's going to be due when I see you next Monday. I'm going to give you more because 4 questions is nothing, but the sheet that I'm going to give you, it's a whopper. It's a lot of practice. It's not due Monday. I'll say it's due next week, Wednesday. You can take more. If you get it done, some of you might even get it done today. There's going to be a wide range of how fast you get. So give me a second. Let me get you the sheet. So take a look at this. I called this using the constant acceleration equations, and all I've done is I haven't given you the word problems yet. This is purely so you can practice that formula manipulation little trick, the rewriting of the equations. I put the 4 equations on the top. Okay? Solve. Remember DFIC, actually I've done the D part for you. I've listed the data in each one. Identify, because the main skill here right now, Noah, is can you find the correct equation? Identify the equation, rewrite it to get the variable by itself, plug and chug and solve. The toughest equation, that one there. The second toughest, that one there. You may find it easier. You may find it easier when you're doing your fancy schmancy formula manipulation. You may find it easier to think of this one as D equals VIT plus 0.5 AT squared, because you guys suck at fractions. You don't quite always know how to deal with them. Sometimes it's helpful to think of it as a 0.5. Sometimes it's helpful to think of it as a 1 on top and a 2 on the bottom. You may find this one easier to think of as D equals 0.5 VF plus 0.5 VI times T, because instead of dividing by 2, that's the same as multiplying each of those by a half. It's up to you. Sometimes on these ones specifically, I'm even going to tell you when you get to around question number... Yeah, no, that's okay. That's okay. Oh, by the way, can you all look at number 14 real quick? Oh, heck, let's do 15. Take a look at number 15. Can you identify which equation you're going to use? Taking a look at number 15, which equation? I heard it. Mark, it was you? Go ahead. Okay, you're going to use this. Mark, what's number 15 asking you to find? You've got VF almost by itself, but you don't quite. What you really have is VF what? How do I get rid of a squared? Really what you're going to do is write that and then square root your answer. So you're going to have sometimes where there's a squared, whether it's a t squared or a VF squared or a VI squared. How do you get rid of a squared? Square root. I haven't done one like that with you. I'm curious to see if you'll figure it out. Otherwise, I'll talk about that next class. The other one I want to talk about, let's erase that, is, no, that's good. That's good. Must have been further back. Maybe it was 12. Yeah. You know what? I'm going to let you wrestle your way through. I'll take questions. I think it's good for you to kind of butch your way through this. So your homework officially 1 to 4 from the lesson. You can try and do them on that paper or on a piece of paper. I don't care which. And then, but using the constant acceleration equations, I think you have enough room to show your work on this piece of paper if you want to. Or you can do it on a separate piece of paper, I don't care.